physics students, and welcome to your first online interactive lab with me as your lab technician. So this lab, we're going to be taking a ball and we're going to be throwing it above a motion detector to find out what happens to its kinetic energy and potential energy, and then its total energy as it's in the air over the motion detector. But the first thing we need to do before we can do any meaningful calculations is we need to know the mass of this ball. So I'm going to use our balance here to find the mass. I don't really know what it's going to be, so we'll start by moving the 100-gram one. Okay, so it's not that. It's apparently more than 200 grams, but less than 300 grams. So let's find out what the mass actually is here. Okay, so it's 290 something. If you've never used a triple beam balance, you're learning something here. So the three things tell us what the mass is, and it looks like it's 291 grams. So we're going to write that down, 291 grams, but in kilograms, that is 0.291 kilograms. So that's what we care about. Here is that value, 0.291 kilograms. Write that down on your worksheet. All right, so we're going to be using this setup here in order to do the lab. What we have here is a computer with a data logger program on it. We have a data logger here, data logger. This is a machine that takes data from an input and then puts it into the computer as numbers and stuff into a spreadsheet. And then we can graph it on the screen. So that's what's set up. Down here we have the motion detector. So this thing actually emits tiny little sounds that sound like click, 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 but really fast. And basically it works like a bat. It does echolocation of the ball when we throw it above the motion detector. And then it sends its data through this machine here and then into the computer, which interprets the information. And it will make some nice graphs for us, so we'll be able to interpret those later. You'll be sketching those on your worksheet. Now, in order to do this, I just said this works on echolocation, but it'll detect anything that's above the motion detector. So if I toss this ball and leave my hands there, we're going to get data for my hands instead of for the ball. So that means that I have to throw it in a very strange and odd-looking way in order to have my hands not be in the way. So it looks like this. Okay? And then if I do it correctly, then the motion detector only detects the ball and not my hands. So then we'll get a nice smooth graph of the ball's motion above the motion detector, like this. Okay? If the ball moves out of the path, we'll see the data go all the way up to the ceiling, and then we have to redo it again. Okay? So that's the plan, and let's get that set up. So, in order to get started with our trial, we're going to need to first click a button here. When I push this button, it looks like a play symbol. It'll actually wait. It's going to wait for data input. So it's going to wait for me to throw the ball when I push that button. So hopefully this works out. Usually you have a second person to click the button for you, but hopefully this will do it. So, ready? Okay, looks like we got good data. So we'll have a screenshot of this in just a minute for you to do your lab worksheet off of that, okay? Okay, but before I show you the data in a good way that you can interpret, I'm going to show a couple other things that I mean. I told you to mark on your sketch of the graphs. One of your instructions on your sheet is to mark where the ball is rising, falling, peak, and caught. Okay, so I want you to mark those with an R, P, F, and C on the sketch of the graph. So you don't have to have numbers on your graph or anything. Just sketch it, right, to the same shape as what you're going to see in a minute when we put the screenshot up. But first I want to show you what I mean by rising, falling, peak, and caught. Or rather, peak would be second. But anyway, when it's rising, that means the part after I've thrown the ball. The peak is when it's up at the top and has stopped moving up and is about to start moving down again. Then, of course, falling is when it's on the way down again. And then caught is when I catch it. So I want you to mark those four things on your sketch of your graph for both the potential energy graph, the kinetic energy graph, and the total energy graph. I want you to mark on there R for rising, P for peak, F for falling, and C for caught. So just put those letters on the graph at the parts that match when that happened, right? Because remember, the graph is the motion of the ball and its energy as it goes. So you're going to mark on the graph like where the ball was physically at that point on the graph, okay? So that's what that means when I said to mark with an R, P, F, and C. All right? That's about it for that. We're going to go ahead and put up a screenshot of this, which I have adjusted the axes so it's much easier to see what's happening. Okay? Okay, so that was the data that we got from this lab. You should be able to now answer all of the questions on your worksheet, your lab handout. If you need to, you can go right back to that point and pause it while you do all of your work. Make sure you get the sketches and answer all the questions on the back side. If you have any questions, make sure you email me or leave a private comment on the assignment, and I always get an email for that as well. So there you go. Hope you enjoyed.